Hey algebra students, let's learn about linear inequalities in two variables. Now today's learning target is that after this lesson you can graph solutions to linear inequalities in two variables. Now before we move on, let's do a quick review of our previous sections in this unit. When do we have no solutions, infinite solutions, or one unique solution to a system of equations? Well, we know that solutions to a system of equations is usually the point of intersection. And most of the times we have one unique point of intersection, like this example that I'm showing you here. There are two lines, and wherever the two lines meet is the one unique solution to this system. So when can we have no solutions? Well, when do lines never ever meet? We know that parallel lines will never ever ever meet. So therefore it can never have a point of intersection. So there will never be solutions to systems like this. So then when can we have an infinite number of solutions? Infinite number of solutions mean that there are multiple or an infinite amount of points of intersections in this system. So if we have a line like this, and there's another line right on top of this, meaning it's the exact same line, then that means that these two lines intersect at all the points. So therefore, we have an infinite number of points of intersections, so infinite number of solutions. Linear inequality is similar to a linear equation, but instead of the equal sign, we have an inequality symbol, like less than, greater than, less than or equal to, or greater than or equal to. A solution of a linear inequality is any ordered pair that makes the inequality true. So let's look at number 2. How can we tell if the point given is a solution to this system of inequality, or for this inequality? Well, just like with equations, you would take the x and y coordinates of this ordered pair, plug it into our inequality to see if it's true. So let me do that with A. So since y is 4, we'll have 4 is less than 2 times negative 2 plus 1. 2 times negative 2 we know is negative 4, and negative 4 plus 1 is negative 3. Is 4 less than negative 3? No, this is not true. Therefore, the point negative 2 and negative 2, 4 is not a solution to this inequality in problem A. Now with B and C, let's try the same thing. 3 minus 4 is negative 1, and is 1 greater than negative 1? That's true. So this one is a solution to this inequality. Lastly, 1 is greater than or equal to 1 minus 7. What is 1 minus 7? It's negative 6, which is less than 1. It does make the statement true, so yes, C is also a solution. Now let's practice graphing these equations and inequalities. So the equation y equals 3x. Well, the y-intercept here is 0, so that's where I'm going to start. Let's make this slightly bigger. And then the slope is 3, which means it's like the fraction 3 over 1, where the rise is 3 and the run is 1. So I'm going to go up 3 over 1, up 3 over 1 to create my line. So there we go, connect the dots. And this is my graph to the equation y equals 3x. So for the inequality, Well, I'm going to start graphing it the same way. Start with the y-intercept, which is 0, then use my slope to figure out where the line would go. And then since y is greater than 3x, I know that my line should actually be a dashed or dotted line. So let's do that really quickly. Wow, that is way too big. So it's hard for me to make a really straight dotted line on the computer, but I hope you get the point. And then after we have this dotted line, since y is greater, we're going to shade this region above our line. Hopefully you guys remember doing all of this from our previous section. So now let's practice doing or graphing the equation inequality y is less than or equal to 3x. So again, y-intercept is 0. Use our slope to figure out where the points will lie. Since this is less than or equal to, we can draw in a solid line. And this time, since the inequality is less than y, I'm going to shade this region under the graph. There we go. So when you graph solutions to linear inequalities, follow these steps. First, graph the boundary line by using the y-intercept and the slope. And pay attention to the inequality symbols so that you know whether to draw a solid line or a dotted line. Then pick an x or y, pick an x comma y value to test the point to help you determine which direction to shade. And as we know, if it's greater than or equal to, we typically shade above the line. If it's less than or equal to, we typically shade below the line. Picking a point like 3, 4 or something like that to test out a solution is also another great method to help you figure out which direction you should shade. At the end, you're going to write your solution as an inequality. So let's try graphing the solution to this inequality. 5x plus 2y is greater than negative 8. First thing I'm going to do is make sure that this inequality is solved in terms of y. So I'm going to move the 5x over by subtracting 5x from both sides. So I get 2y is greater than negative 5x minus 8. Then we need to divide by 2 to get y alone. So I end up with y is greater than negative 5 halves x minus 4. Now let's start graphing. Again, use the y-intercept, which in this case is negative 4. Then use the slope. It says down 5 over 2. Since it's hard for me to go down 5 and over 2 to the right, I'm going to go backwards. Go up 5 and over 2 to the left. There we go. Now, should I make a dotted line or a solid line? In this case, since it's greater than, I'm going to make a dashed or dotted line. I'll try to make it a better line than before. Okay, I think that's slightly better than before. And lastly, figure out which region you should shade. Since y is greater than this expression, we're going to shade above this graph. So all of this space over here will be colored in. If you do this on paper, it might be better to do it with something like a highlighter. Lastly, if you really want to check if you shaded the correct region, pick a point that's inside the shaded region, like 0, 0. And then plug it into your inequality to see if it makes the inequality true. So if both x and y were 0, we would have 0 is greater than negative 8, which is true. Therefore, we know for sure that we shaded the correct region when graphing this. For 4b, again, I'm going to start by solving this inequality for y. If I add y to both sides, I get 4x plus 2 is less than or equal to y. Y-intercept is 2. Our slope is 4, so up 4 over 1. Oops. There we go. 1, 2, 3, 4. Yeah. And then maybe backwards, so down 4 and over 1 this way. Since y is greater than or equal to, I know that I can draw a solid line for this one. And you really want to pay attention to inequalities like this, where the y is on the other side. Y is actually greater than or equal to all of this 4x plus 2. Therefore, we're going to shade above the line. For this one, make up your own inequality and teach someone at home how to graph inequalities and find solutions. Have them write you a compliment on your teaching and learning, and hopefully that will help you also figure out what the correct way to graph inequalities are. This time we're going to take it one step further and write an inequality from the graph that we see. So first thing you need to do is, well, figure out this equation for the boundary line. I know that the y-intercept is negative or positive 1. And for the slope, I see that here is a point. I go up 1, 2, 3. So the rise is 3. And the run is 1, 2, 3, 4. There we go. So I'm going to have y is something with 3/4 x plus 1. Since the region above the line is graphed, and know it's greater than, and since our boundary line is dashed, I'm not going to put an or equal to symbol. So this is our final solution. For the graph on the right, the y-intercept looks like, I think this is going by 2. It's 2, 4, 6, 8. So this seems to be -5 for our y-intercept. The slope, well, let's see. I go down 1, 2. Actually, sorry, it's going by 2. So 2, 4, 5. So I'm going down by 5, -5 for the rise. And for the run, we're going over 2, 4, 6, 8, 10 units. So our slope is -1/2. So we know we'll have -1/2 x minus b, or -5. Since the region underneath the graph is colored in, I know this will be less than. And since our line is solid, I know it's less than or equal to. So this is our inequality for the given